Factorize completely. And what we have here, well, I won't say that yet because everything is very clear in the animation. The expression is a quadratic in trinomial form. When we have an expression like this, everyone knows, everyone calls it a quadratic. Why do we call it a quadratic? We have all kind of spurious explanations on the internet. We'll give the correct one right here. However, it is very clear why it is called a trinomial, because it is very obvious right there. We have three terms of a trinomial. So there's your reason for calling it a trinomial. Our first job in factorizing this trinomial is to resolve the middle term into its two components. We have a single middle term right there. We need to resolve that middle term into its two components. And what is the process that we go through in order to do this? We find the product of the two end coefficients. The coefficient here is 2. The coefficient here is -6. The result is -12. What else is there to it? We consider the middle coefficient, which is -1. First, we find the product of the two end coefficients. Then, we take a look at the middle coefficient. Why do we do that? We need the two numbers that multiply to give the product of the two end coefficients, which is -12, and we'll have a sum of -1. They will add to give -1. The product should be -12. The sum should be -1. What do we have there? We have here all of the possibilities, those that will multiply to give 12, but we are taking a look at -12, but we'll do this in a logical manner. For the product to be negative, the two numbers that we multiply must have unlike signs. Also, because this sum is -1, of course, which is negative, the larger one must be negative. When we are adding numbers with different signs, the answer will take the same sign as the larger. This is the result of adding the two numbers that we are in search of, which is negative. Therefore, any two numbers that we are going to add together to give this negative number, the larger one has to be negative. No, we are not saying that there is no other way to get a negative sum. But do not forget that the product is -12. Therefore, one must be positive and one must be negative to give a -12. The sum is required to be negative. Therefore, of the two numbers that multiply to give -12, of which one must be positive and one must be negative, the sum is negative. Therefore, the larger one must be negative. And we are going to demonstrate that right there. In each case, we assign a negative sign to the larger one. We are on our way. Which combination will give a -1? Because all of these have a product of -12. Which one, which combination will give a sum of -1? -4 plus 3 is equal to -1. We therefore have the coefficients of the component middle terms to be -4 and +3. -4 and +3. Initially, no 1 was given there, but we know that when there is no coefficient, the default coefficient is 1. So we have included the 1 right there. So the two component coefficients are -4 and +3. Now what we will do is rewrite this expression. The two end terms will be the same and the middle term will be resolved in its two components. 2x will return. The -4 is one coefficient of the middle term and the other one is +3, and the -6 will return. -4 will be one of the coefficients and +3 another. And there we have our expression with the middle term resolved into its two components, which results in 4 terms for the entire expression. We have 4 terms. It is quadratic because its pure form or original form has 4 terms. It is trinomial because the two middle terms are like terms and are combined to give 1 term. This original expression that this is coming from is, as a matter of fact, a quadratic. Quad, as in quadruped, as in quadrilateral, as in quarter, that all of those numbers have to do with 4. And your quadratic also has to do with 4. As a matter of fact, in its pure form, it has 4 terms, of which 2 are like terms and are combined to give 1 term, and that is why its existence is in a trinomial form. We will factorize by grouping, and of course we'll take the terms 2 at a time, and we have singled out the first 2 terms right there. And what do we know? The first 2 terms have a common factor of 2x. 2x is a factor of this term and this one, and the process that we will go through is to divide each of the terms by the common factor. Each term will be divided by the common factor of 2x, or which is 2x. Next, of course, we see the 2's cancelling from there, and x into x squared is x. So we do that conveniently by removing the index of 2 right here, which will cause just x to remain. And that is a way that we improvise our cancellation process. Of course, 2 into 2 is 1, and 2 into 4 is 2. Finally, the x's are cancelled. Now, we have our factorized form. The common factor is 2x. In the brackets, all that is left for the first term is x, and all that is left for the second term is 2. The other 2 terms have a common factor of 3. Take the common factor and divide each term by the common factor. Just like the first pair. So the second pair of terms have a common factor. That's the second pair. Have a common factor. Those terms have a common factor of 3, and we will divide each term by the common factor of 3, and we will see 3 disappearing from the first one, and 3 into 3 is 1, 3 into 6 is 2. Therefore, what we have here is our common factor of 3, which will be accompanied by the x that we have here, and what will remain is a well, we have to carry the negative sign with us, 2. So the common factor is 3, and the remaining factor is x minus 2. What is required by the examiners, what is required by the statement of the problem is a complete factorization. What we have there is a factorized expression. It is factorized, but it is not factorized completely because we see a common factor there. The resulting expression has a common factor of x minus 2. Therefore, further factorization is possible. And we will take the large terms, which we have 2 large terms, of which x minus 2 is a common factor, and we will no doubt divide by the highest common factor, which is x minus 2, which is probably the easiest division that we have since we have started the factorization process, because we can see that x minus 2 will cancel right there, and the same will happen right there. We are left, therefore, with your common factor of x minus 2 and the remaining factor of 2x plus 3. 2x plus 3. Sometimes students just put numbers into the second pair of brackets without understanding why it is done. We are demonstrating right here the complete process of factorization. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.